Tonight we have two speakers. So the very second speaker, not the first one, is Nikita Ivanov, right here. He is the CTO of GridGain, the founder of Apache Ignite, and way back in 1996, he was among the pioneers using Java for server-side middleware. But now we're going to welcome, for our first speaker, Rachel Padreski, She's the solutions architect for GridGain, as well as the official Apache Cassandra Evangelist. Please welcome Rachel.
I was the Apache Cassandra Evangelist. That's the, I'm now here to talk to you about Ignite. Has anybody heard of Apache? Yeah, I'll turn it on. Has anybody here heard of Ignite before? Before coming to this thing and getting frisbees thrown at you? Come on, show of hands. Come on, Lizzie. All right, excellent. All right, who's putting Ignite in a POC right now? Anybody? Hands up. Nice. Anybody's got it in production? Excellent. So 3 out of 100 or so. Good, good. And then you're here to learn all about Apache Ignite. What? Nikita, you're going to have to do something about this. Can you guys hear me all right?
Not really,
No?
Can you get closer up the mic?
I can put it closer up
to your neck.
Yeah, these things are really not designed for women's clothing already. Can I talk like this? Nope.
Is it on?
Hello?
Yeah, it's on.
It's on. I can talk like that. Can you hear me now?
Did you know the Verizon guy got nicked by Sprint?
Yes.
Hear me now, guy?
More random trivia. I did have to test my slides 5 times, but I didn't have to test my microphone. That's the problem.
All right, how about if I talk really loud?
Yeah, that works.
People in the back? Yes? No? All right, I'm only talking for a half an hour so I can keep up this, this volume. All right, okay, if you're not using Ignite, who's using an in-memory solution at the moment? All right, excellent. Who wants to use an in-memory solution? I want a real good show of hands for this one. Because the rest of you who are not having your hands up, I'm going to try to convince you by the end of this 30 minutes that you will want an in-memory solution. And if you don't want an in-memory solution and you don't have one, then why are you here? I guess that's the bigger question. For the frilly flyers, right? And the pizza.
Yeah.
All right, so let's take a look at a bit of a history lesson. First off, let's talk about the cost of memory. I actually pulled out this research on the plane. I live in San Francisco currently, so there was about 6 hours I had a downtime today. And to the glories of the internet, I found out that in 1980, RAM used to cost $10 million for a gig. And a disk drive would be $1 million for a gig. So prices have come down a bit in the last few years, to say it lightly. Somewhere in here, there's an SSD, kind of starts in the 2000s. It's kind of closer to the hard drive prices, flash, but we're definitely, the price of RAM is definitely coming down significantly. To the point where when Nikita and his partner Dimitri had started GridGain with the Apache Ignite project, they had to pretty much pioneer distributed systems because the idea of having enough RAM in order to run anything of any significance, you couldn't put it on a single machine. So even 10 years ago, it wasn't possible. So in order to get enough memory to make anything meaningful, they had to make it distributed. So today, we can take advantage of their work and products like, if you've heard about Cassandra or some of the other distributed systems out there, it definitely is the way forward. We're going to be talking about that in a little bit. So how much do you guys think a terabyte of RAM costs today without looking at the slide? A few hundred?
Yeah.
Yeah. So if you have, if you got about 100 gigs of RAM per machine, you got about 10 machines, it's going to cost you about $20,000 or so. So a terabyte, 100 gigs, is going to cost you in and around $20,000. So for the cost and also the other question is, does anybody know the working set of Twitter? Well, this is probably about 2 years ago. how big the working set of Twitter is, which is about a week's worth of tweets. Anybody work with that? 1 terabyte? Up? About 7 terabytes. So the working set of Twitter about 2 years ago was about 7 terabytes a day. There's probably a little bit more now. So for the price of a nicely equipped Tesla, you too can have enough memory to fit the entire working set of Twitter for your own perusal. Just think about that for a second. So this is like little mark number 1. If you're not thinking about doing in memory, why not? So for, or you could drive a Tesla. Wait a second. I have to think about that logic here for a second. So we're going to start with a brief history lesson here. So we're going to start in the 1960s, the era of non-volatile storage. And DRAM first unveiled in the mid-1950s, but the amount of memory on machines that sent Apollo to the moon was the amount, was how much? Does anybody know? You actually answered it earlier. 4K. That's how much memory, and it looked like this. Isn't this great? This is read-only wrote memory. About 4K of it. This is the actual one that went up to the moon. And how much? And this is about the equivalent of a pocket calculator today, right? Your iPhones, your iDevices are infinitely more powerful than the machines that took Apollo to the moon. And we won't even talk about an iPad or even this laptop that made these beautiful slides. Whoa, that was loud. Well, that didn't. If I didn't wake you up, that certainly did. No idea what triggered that. I shouldn't have done that. I shouldn't have lifted up my laptop. That's a really bad idea.
Is it the dongle?
I don't know. I'm going to not touch my computer again. How about that? Thank you. All right. Anyway, so as I mentioned, I live in California. I flew out today. I made a reservation. The reservation came through a system called Sabre. Sabre was designed in the, anybody know? 1960s, that's right. And it was one of the first applications out there to use a relational database. So the next era we have is the era of hard drives in the 60s and the 70s, and this enabled us to use relational databases and power some great applications, including Sabre, which was before that done by hand. So people used to have these big bulletin boards, and they used to fill seats with little slots of paper. Not going to work in today's day and age. But also at that point, the first DRAM was invented, and it looked a little bit different than the rote memory. So if anybody can tell me afterwards how you actually programmed that rote memory that we saw earlier, I'll have a prize for you. So in the 2000s, we start moving into the era of Flash, which was a good thing because we were getting into the world of web applications. I actually do remember working in the early 2000s on web apps, and the types of things that I had to do with memory was basically configuring swap. Like I spent most of my day just trying to use the little bit amount of memory that I had in my app servers or on my database to get as much mileage as I possibly could, so my web apps would run at some type of speed that was not down for the most part. And later on, because of the fact that we were doing terrible things to MySQL, we ended up taking relational databases and creating distributed systems. So the Mongos, the Hadoops, the Cassandras of the world were unveiled about this time. In order to take advantage, and they could take advantage of Flash and distributed systems and, keep those horrible things from happening to a sharded MySQL system. Last but not least, we end up with the era today, or the era of RAM. We saw earlier that the price has come down that makes it actually usable. So this nice gentleman who gave us our iDevices and all of our mobile apps, and now we're talking about, instead of hundreds of thousands of users at a single time, we're talking about millions of users at a single time on our phones, on our mobile applications. Now the question is, if you're going to be creating an application for the next generation, a mobile app or an app that's going to be used internally, are you going to want to use technology that was designed back here, designed to work on hard drives, on mainframes? Or do you want to work with technology that was designed to be the most efficient to take data off disk or off RAM, out of RAM? That's the question that I want to pose to you today. So mark number 2 on if you're not thinking about doing in memory, why not at this point? So it comes down to actually just simple arithmetic. So how many steps does it take to get data off of a hard drive versus getting data out of RAM? So you start, when you're trying to take data off of disk, you start with an API call, you demark the data, you go to OS/IO, IO control, then a disk, and then you go all the way back again. And this takes milliseconds in a well-configured system if you're lucky. But if you have a memory-first architecture, you're talking about an API call to pointer arithmetic. That's it. This ends up being hundreds to thousands of times faster than any type of access off of flash or off of hard drives. I have had conversations with Gartner about some distributed systems that I've worked on, and they asked, well, so where's the in-memory component? And I said, well, what do you mean the in-memory component? They said, well, this is what it is. The new RAM is the new disk is the new tape. Gartner is convinced that memory is going to be the way forward, to the point where it convinced me to actually join GridGain. So I left my work working on distributed systems with Cassandra in order to start working with Apache Ignite, because not just Gartner, but I was seeing that I could no longer fulfill SLAs of 1.2 milliseconds for reads and about 0.6 of a millisecond for writes. That wasn't fast enough anymore. Things needed to be going into memory. And with the price of memory going down, that's why I've chosen to work with in-memory technology. So let's talk about this in-memory technology called Apache Ignite. There's already a little bit of a spoiler. 2007 was the first version of GridGain. And in 2014, GridGain actually donated the project to the Apache Foundation. It went into incubation, and it graduated in late 2015, August 2015. And it was the second fastest project to graduate after Spark. So it moved incredibly fast. What's important here is that this, even though it graduated in 2015, this is mature technology. There's over 1 million lines of code. There's over 60 contributors to the application. It is incredibly robust. So the rest of the presentation that I'm going to be going through today is to walking you through what are the components and what are the features and the benefits of the Apache Ignite and the GridGain solution. Nikita will take over after I'm finished. Actually, how am I doing on time? Talking about use cases and where the project is going to go from here. Oh, I have 9 minutes, eh? More or less? All right. All right, whose system currently looks something like this? There's an application that talks to a database. Raise your hands. Come on. So what was I going to say that if you wanted an in-memory solution, and you didn't actually have to change this? So that's what Apache Ignite does. It actually just slides right in between your application and your system of record. And if that system of record happens to be a database, Ignite is a Java-based middleware infrastructure software that slides in between your traditional data sources, your databases, your file systems, HDFS, whatever you have, and your applications at the top. It slides right in the middle, and it provides fundamentally speed and scale. It provides you speed by moving data from the slow disk that we talked about earlier and flash-based devices into RAM in a across distributed computers. So its first benefit is in memory. We talked about why that's good. There's 2 ways that it does the in-memory portion. It does it as a key value store or as a file system. And a key value store was chosen because it's just sort of the most basic level of data storage. On top of there's a number of APIs, including SQL, C++, Java. We'll go through them in a little bit, about how to actually access the data out of that key value store. There's also a file system option, so you can treat it just like a file system with all your traditional inputs, DES, etc. Second is always available. So one thing that happens if your database goes down, what happens to your application? It'll go down. Now you can spend some money on replication software, do active data centers, or you can start bolting on new solutions that will keep your application running. But for the most part, it's a single machine. Ignite is a distributed system, and there's still failover built into the system. So you might have your data partitioned across the nodes in your cluster, and there'll be backups for each node. And that works very well for incredibly fast writes that have, if one of those nodes goes down, you'll have other nodes to write to. For reads, you may want to fully replicate it. So every node in the system might have an entire version. So you can have multiple clients all talking to different nodes in the cluster and being able to read data. There's also automatic data center failover, network partition, and rolling upgrades. So you can architect a zero downtime solution using Apache Ignite over your existing system. Scalability aspect, it's linear scalable. You need more capacity, you need more RAM, you add more nodes. Simple as that. And those nodes themselves can be, you can put your working set on heap or off heap. So we can take advantage of all the data that you have on your machine. You're not just limited to the JVM. But say you have another type of system. Maybe you have a NoSQL system like Cassandra or Mongo or another type of data. Like, hey, Rachel, I've got the always available. I've got the scalable bit. But what you don't have, if you have a NoSQL system, is SQL. And has anybody worked with a NoSQL system in here? Anybody had to remodel their data? Is that fun? Yay. Hours and hours of my life talking about how to remodel data in order to get these things to work. Wouldn't it be nice if you could just use the same old SQL that you've been using in your application so far? ODBC, JDBC? Well, that's what Apache Ignite gives you. So not only can you have full ACID transactions, none of this cap theorem, no choosing C's and A's or A's and P's or C's and P's. You have full ACID transaction with a SQL 99 interface and native in-memory MapReduce. So your access layer to the system doesn't have to change. So previous to working with Cassandra, I spent the next 10 years of my life working on data warehouses. And what does data warehouses mean? At the time, it meant lots and lots of ETL. So I spent a lot of time moving data from one system to another. So one of the benefits here of Ignite is that you don't need to move your data from one system to another. There's no need to ETL. You'll be able to get this automatically by just putting Ignite in between your application and the database. Last but not least, want to make sure that this is specifically for Nikita, that your sources can be HDFS. So if you are working in a data warehouse environment, in a data lake, in more of an OLAP environment, you know what? Hadoop's mascot is not a jackrabbit. It's not the fastest thing on the planet. Kind of slow. Wouldn't it be nice if we could put that into memory? So actually, Ignite will do in-memory MapReduce with an in-memory file system. So you can speed up your Hadoop jobs 10 to 100 times. But where would Hadoop be without good old Spark? So you could have a Spark application that actually pins the RDDs into memory to share across your Spark jobs, or you can actually just save the RDDs to the in-memory file system, and as Spark jobs work on them over time, they can keep using the same ones, opposed to just standard Spark, which as soon as you use an RDD, it's gone, disappears. So all this with zero downtime, zero rip and replace, will work with all your existing infrastructure. So this is our famous architecture slide. You got to throw one of these into every presentation. But if you look at the GridGain's website, they talk about GridGain Apache Ignite being a fabric. So what is a fabric versus a grid? How I like to describe a fabric is that it can actually enable all the different applications that you want to do in memory all in a single piece of software. So if you want to be doing streaming or CEP, compute, data, Hadoop acceleration, it's all a single piece of software, one installation, and you pick and choose the APIs that are appropriate for your application and for your use case. One thing I do want to actually point out is the compute and data grid. So distributing a long-running application over multiple computers is kind of a no-brainer, right? You have a long-running job, you can distribute it around a cluster. Ignite provides you that capability. Simply, zero deployment, you can change a comma in your code, you don't have to redeploy it, you don't have to redo your JVM. You basically get a supercomputer from 10 different nodes of Ignite, for example. But what's very nice is when you combine that with the data grid, you get co-location. So you can actually execute your code on the data on the same node in the same memory space as your data. So your code and your data co-reside working in the same memory space. Now think about what that's going to do for high-frequency trading applications, for example. I have about a minute, unfortunately. Is there any questions so far? Yes?
You said ACID. What consensus you have? Raft, Paxos, Zookeeper?
We don't actually, we don't use Paxos. We don't employ any of those protocols. It's actually just a fully consistent platform using optimistic locking, pessimistic locking, serializable, everything you would use in a standard database. And you can ask Nikita if you want to know the details.
So
he's the one who wrote it.
Are you actually caching solution for the data which is persistent?
Well, caching is one portion of the system, correct. So you can, as your application writes through the grid or reads through the grid, it will cache any data that is not actually in the memory at that point.
But usually application will write down there to SQL, NoSQL, or Hadoop, right?
So
and you are the caching mechanism.
We're the caching mechanisms. We do actually integrate with Golden Gate. So if you did want to do some sort of change data capture where an application was writing down here and that your applications were reading, you'd probably want to employ Golden Gate or some sort of CDC application there. Otherwise, we would say you wanted to read and write from above Ignite through either a write through, a read through, or a write behind, read behind capabilities there. But yeah, fundamentally, we're talking about a caching layer.
So persist the data into this gray area?
You could persist it there. You don't have to though. If you could persist it into the
so
grid
if it's
itself.
not me, who will do that? You're saying I don't have to. So if I don't have to, somebody else.
Well,
has
you
to.
can
So
persist it
who
into
else
Ignite.
will do that?
In Ignite itself, you can persist the data into Ignite. And just give a few minutes, and Nikita's going to talk about a new feature that's coming out that will actually make that a little bit more clear.
But basically, this is actually me, Nikita. The data storage is the gray ones that you see at the bottom, are completely optional. The Ignite is today, not 10 years ago, but today, Ignite is used predominantly as a system of records. It doesn't need to have any disk-based storage. You may have it, and just for legacy reasons, we can read through it, write through it, just for your benefit. But we don't require it. We have a completely fully available, fully transactional with the ACID properties system of records in memory across multiple nodes.
But what if cluster will go down?
We have a full ability to replicate data across multiple nodes. If your entire cluster goes down, then we have a data center replication as an option. If you want to be safe in this case, use data center replication for that. But our transaction implementation probably, and I can say this straight face, second to none, we use the same MVCC model as the traditional database like Oracle and DB2 would use. So we have the same ACID properties and ACID transactions, both pessimistic and optimistic, as any normal database.
No, but there is an understanding in today's world, for example, that it can be some calamity like, terrorist attack or something, that the entire thing will go down. In your case, if it's not backed up by any, permanent storage solution, the whole data set will be wiped out.
Right. If you don't use data center replication, it will be.
Well, who will agree to that?
There is a different. Well, there is a. We use probably by 5 out of 10 major banks of the world today. And in each bank, there's plenty of data sets that are not critical. Critical data sets, not the entire bank, but critical data sets can use data center replication. And your data will be replicated across multiple data centers, geographically distributed. So that's an option for you if you like it. Naturally, that will come with some penalty and performance for that particular data set. But you can have multiple data sets, sometimes dozens and dozens of different data sets in your systems that can be configured differently.
As we know, like software problem can bring down the whole cluster, including cluster distributed by multiple data sets. We can't guarantee that some desk packet won't come in and won't bring down everything. In regular database, I have durability.
And in this case, you can have a durability as well. So if that's what really cool about Ignite is that it doesn't really enforce any of the decisions on you. If you want to have an absolute safety, fine. Use disk-based durability and use data center replication. You're going to be as secure as traditional Oracle databases proven by a number of major banks that we used it. But again, it's entirely up to you. We don't enforce any of this. But I can tell you basically that about 50% of our usage globally today is when people use Ignite as a system of records without any disk-based storage. Because we replicate data across multiple nodes, it gives you multiple nines of uptime. And for a lot of data sets, that's perfectly enough. But that's a good question, by the way. Don't get me wrong, it's a very good question. And the bottom line, we allow all these configurations. We're basically talking about some edge cases, and we have to support them.
Yes, we saw Amazon down because of some wrong configuration, not because of hardware.
I found it really doubtful that any serious enterprise or business will allow the system that they depend on not to be persisted anywhere.
You're almost right. But when you say this, there are different data sets. The some data sets within any financial organization, talking about financials, can be completely safe with just in-memory storage. They can be replicated. Even if you lose them, you don't lose the business operations. Some of the data sets, you're absolutely right. They have to be backed on every transaction on the disk just to be safe. And we support that.
Hey, I'm going to have to say we're going to take it
The
offline.
hook is coming in here.
Yeah.
Come on up, Nikita.
Yeah, it's your turn, Nikita. Come on.
Rather speak with your back to
All right.
the audience. I think they want to see your face.
Not my butt, huh? All right, so what I'm going to talk basically, we kind of split this so we don't get completely crammed in one presentation. So Rachel didn't have enough time to talk about some of the GridGain, Ignite stuff, and GridGain stuff, and let me make sure that I get all my stuff in. All right. So, a couple of points, by the way. How about this? If you have a guy's question, you can hear me in the back, right? If you have questions, let's just not wait for the kind of Q&A. We're going to have an end of it. Let's just go ahead right away. So, another comment I want to make is, think about this. If you're new to this, if you've never heard about Apache Ignite, about the memory computing in general, it's kind of my expectation. Don't get alarmed if you're confused about what the hell it is, because it doesn't really fit any kind of existing mold of either app server or a caching solution or anything else. Apache Ignite is a fairly new thing, and it's an evolving thing. We currently call it a in-memory data fabric. I kind of like this name. I can explain it to you, but keep in mind it's an evolving thing. It does too many things. And sometimes it's a wrong thing to do too many things. But for now, we believe that we provide you this kind of, a strategic view on in-memory computing. Because if you think about what's in memory, if you think about what Rachel just said, It's no different. We just moved our data storage from a tape or disk or flash into the RAM. What's the difference? The difference is the RAM is a byte addressable. That's about the only difference, and it's faster. I mean, if you compare some of the flash solutions, it's, you know, it's maybe 10 times faster than some of the best flash. The biggest difference, it's byte addressable. We don't have to do the block level device. There's a lot of optimizations around it. But that's about it. The rest of it, you know, how do we process data? How do we access? How do we store it? It's all the same. So that's why we developed Ignite for the last 10 years to really give you the same capabilities, but now on RAM, right? How do you transact? How do you process? How do you do HPC? How do you, do failover? How do you do, key value access? How do you do SQL? All the same things we've been doing for years and years. So, if you're confused by now, don't worry about it. You should be confused because it's a fairly new thing. There's no standards. There is no any kind of, standardized approach to memory computing. We're still evolving this. So that's kind of, one of the comments I want to make. So what I want to basically do in the next, let's say, 15, 20, 25 minutes is to give you some overview of what Apache Ignite 2.0 would look like and some of the ideas, some of the thoughts. Again, this is very preliminary. We're just starting the discussion in a dev list. And by the way, another comment I want to make. That's the beauty of Apache organization. It's completely open for every one of you. Anybody is interested in joining Apache Ignite, not only it's obviously free, but it's a very fun community. You can pick any task, any job you like, anything you wanted to do. Just look around, maybe do something, documentation, testing, some of the features, some of the very cool features still available for us to develop. It's a very welcoming community. It's the biggest difference between everything else, like on GitHub and Apache. In Apache, it's all about community, all about all of us and you who will enjoy it. It's completely free. Welcome to join, by the way. And you're going to be part of this conversation. So, what's happening right now on that list, we're trying to discuss what the Apache 2.0 would look like. And the kind of consensus on at least in the background of this conversation is that we want to move towards a converged data platform. And it's a pretty kind of a loaded term, right? It looks like architecture, but let me try to explain the thought process behind it. And it gives you some of the ideas of where we're trying to move. And it gives you some of the ideas where actual in-memory computing is evolving, because it's really different from what it was 10 years ago, which was exactly as you mentioned, just the caching. And what's really interesting, at least to me, that as of today in 2016 and go look at in 2017, caching is the least interesting part of the in-memory computing. This is like literally a low-hanging fruit. Every goddamn database had caching for the last 25 years, nothing new there. So where are we going from there? And I think, the converged data platforms that you're going to hear from us and from Hortonworks and from Cloudera and from Mapar and from all the different guys, this is the term that you're going to see a lot. So let's talk about it for a while. But before that, what is the limitation of Apache Ignite 1.0 or current Apache Ignite? One of the biggest limitations, and I should basically make sure you guys are all aware of this, is that for a SQL access, all the data has to be in RAM. For a key value access, if you're just doing a key value access, data can be anywhere. Data can be in RAM, can be in flash, can be on disk. We already have today a tiered storage model. Data can be anywhere. But for a SQL access, for SQL 99 access, all the data has to be in RAM. Any data that is not in RAM today will not be queried when you do SQL query. It's a pretty big limitation. Not only ours, everybody does the same limitation. Yes?
When you say RAM, do you mean on one machine?
No, obviously across the cluster. So, but it has to be in RAM across the cluster, naturally. It's a fairly significant limitation. And we all admit that because, first of all, it's very hard to track what's in RAM, what's not. And whenever you issue the query, SQL query, it's kind of hard to know what are you querying. So unless you, from application standpoint, guarantee that your entire data set fits in RAM, you kind of cannot use SQL because you have, at any point of time, you have no idea if the data is entirely in RAM. And SQL is extremely important. And I get asked this question, literally every time I meet with customers, why is SQL so important? I keep saying that, well, if you think about a key value access, it only works when you know the key. Obvious, right? What if I need to find all the employees in the company that has a first name as Nikita? If you don't have a SQL, which is the index-based access, if you only have a key value, you're doing a full scan. And the full scan basically kills you from application standpoint. So the SQL is extremely important. And again, SQL currently does not work unless you have all data in RAM. It's true for every other implementation, not only ours. So this is the biggest limitation which we're trying to basically get away in a 2.0 from a technical standpoint. So what is Converged Data Platform? It's kind of trying to address this issue. But it kind of trying to address it from a little bit high level point of view. So we're trying to, if you look at the research papers, right, from Gartner, Forrester, 451, anybody else, they'll tell you the Converged Data Platform literally means a fast data plus big data. Again, it's a lot of marketing talk, but fundamentally it's an idea that can we actually combine transactional analytical processing? Anybody old enough remembers, late 70s, early 80s, where we had that division, where we actually came up with the idea that all OTP systems have to be separate from all lab systems because they're so different. We don't want to tax our transactional system with analytical queries because they were too slow, and the transactions would fall apart for any large data sets. So back then, we separated them. And in the early 80s, it sounded like a fine idea because separation was very small. Guess what? Forward, 40 years from now, we have two different worlds with two different segments in industries and companies and tooling for all the OLTP in the lab. And today, we kind of realize, not today, but in the last, half the decade, we're starting to realize this is the biggest mistake we've made because we need data from both systems. And today, we basically, rely on the ugly ETLs that takes hours and days sometimes to move data back and forth. So the whole idea that everybody is pushing for is transactional analytical processing. Gartner has a term HTAP called hybrid analytical transaction processing. Forrester has a funny term called translytic processing, which stands for transactional analytical processing. No matter what terminology you use, the whole idea is can we somehow combine these data sets and have one system that allows us to run both transactions and analytical processing on that data set. So the idea there is pretty similar. And everybody understands that today you cannot do OLTP without a memory. Because if you do OLTP on the disk, your performance is going to basically be disastrous. So the idea is to basically combine fast data on RAM and the big data on the disk and have it on one system. Surprisingly, you think about this, if you're not into this kind of business or technology, you think, what's the big deal, right? It kind of going to happen the same way. If you look at traditional databases, if you look at like Oracle, it is basically what we're just preaching right now, right? It keeps most of the data on the disk, keeps all the cache in RAM, and that's typically how it's done. But fundamentally, the problem there is in size. The type of the databases, type of transactions, type of processing we're running today on all app and OLTP systems are so different, it's hard to reconcile them. So we need to have kind of new approach, a new type of system. The biggest thing we're trying to avoid, again, is ETL data. I cannot tell you enough how many times I'm seeing a customer who basically saying, look, we have a small ETL that takes like 20 minutes to move data from one Hadoop installation to this, in-memory system on the Ignite. Think about this. Anything more than a few milliseconds of ETL is already killing your real-time response. Look at your iPhones, look at your AI devices. How many apps do you know where you press a button and then you wait for 20 minutes? But I'd say like either an AWS problem or Ethernet problem, but it's not an apps problem, right? We don't have it today. Think about this. I mean, we're really in the last decade, we all grown up to basically say, look, press a button and get a response. I don't give a shit what's behind it, right? It has to be immediate. And oftentimes, especially in our business in finance and whatnot, it's actually a lot of data happening. So ETL is really, it was kind of cool about 10 years ago. We were all getting this, in a low cost data warehousing based on Hadoop. Today, it's almost a, no. And people trying to get away from this. No way people building a new system with ETLs. So one way to avoid ETL is to really concentrate on this kind of converged data platform products. One of them is Ignite, that allows you to basically keep data in place, static, and only basically apply a different type of processing to it. So naturally, kind of circling back to the same slide, to do that, you have to have a disk storage as well in the system. There's no way any of us can have petabytes of RAM, which is still too expensive, still kind of unwieldy. So what are the difference between fast data and big data? Again, you guys know most of it about this, but just very quickly. So the fast data is about OLTP. It's a different term for OLTP. Somehow I grew up with OLTP, now we call it fast data. And big data is all about OLAP, which is online analytical processing. So the fast data is all about read writes, and it's a big difference from the big data. The big data is read only most of the time. I mean, you'll be surprised how many times I've seen people who basically get amused that Hadoop is a read-only system. Hadoop is a read-only system. You can only append to HDFS. There's no writes in HDFS. There's no random writes. So a lot of folks don't realize that. So the Hadoop is a read-only system. You write once to it, then you read and read and read, or you have to delete the whole thing. So the big data is a read-mostly system, if not read-only. So fast data, or what's that with memory, is obviously the small data sets. The big data really shines in the big data sets, goes without saying. What's also interesting that a lot of people don't realize, fast data is all about high throughput and low latency. And those two things are very important. Low latency means how fast a single operation can go, and the throughput means how many operations per second can I go through the system. In an OLTP system and a fast data, both of them very important. Think about a transactional system, you run your trading and whatnot. Every operation is important, and how many operations per second is also important. In a big data system, that's not the case. Nobody cares what's the throughput, because most of the big data systems have the data analyst as the only user. It's interesting, thought to kind of munch on. Think about this. Look at your Spark or Hadoop systems. They only have few users. Think about this. Most of the Hadoop or Spark systems have literally less than half a dozen users at any given time. It's your data analyst. It's people sitting basically typing the code or writing some tasks and whatnot. It's a completely different profile from the OLTP system that can have thousands and millions, sometimes tens of millions of users. Most of the big data systems have literally no users. They have 1 or 2 or 3, maybe half a dozen data analysts hitting that system. It's a completely different profile. You have a question?
This is not entirely true, because even in HDFS, which is, you're right, append only, there is an H-based, transactional system on top of that is read-write in that sense, right. and serious enterprises put multi-tenancy on Hadoop systems, which are literally thousands of users right now. And on top of that, HDFS is not the only choice. There is a MapRFS, which is completely read-write HDFS compatible file system.
MapRFS is different. HBase is, we can argue, HBase is, let me give you one example. HBase works when performance doesn't matter.
Again, we have MapRDB, which is HBase rewrite, which is completely compatible.
I agree with you.
So if you will move to MapR from regular Hadoop, then you have all these things solved right there in the operating system for a cluster.
And I agree with you that basically with MapR use case, they're actually moving in the same direction with us. So but it's nothing to do with the stock Hadoop from Apache. But I agree with you. As far as my take on the MapR has really nothing to do with Hadoop at all. It's a proprietary / open source software that looks like Hadoop, but no longer Hadoop by a large margin. Because if you want to use Hadoop, you download from Apache. MapR has its own system. But by the way, they call it actually, I think, Converged data platform or something like this, or Fabric, something like this. So anyways, that's a very important point about the throughput and low latency. So, these things sometimes kind of escape you, but it's kind of important to look at them this way. And this is the bottom line there. The fast data is predominantly for machine-to-machine processing. How many times you have human being in an OLTP system? Never, unless it's a DB administrator, right, or something like this. But on the big data, it's all about human interaction. Therefore, latencies and throughput are not that important. So that's why there's two different worlds, and it's kind of hard to reconcile them, at least in a kind of novice way. But let me give you a couple examples of the system on the fast data. So when we talk about a fast data, we predominantly talk about two different types of system today: in-memory databases and memory data grid. And I want to give you a kind of quick overview about them so you guys can have a good sense. So in memory databases, it's typical MemSQL, VolDB. How many of you guys use those great products? Excellent. So those are really good products. Both of them I like. I like MemSQL a lot because they have a founder and CTO called Nikita as well, so a bunch of Russians. And they're right there in and out neck of the wood in San Francisco. So they're great products with one major caveat. They are SQL only. Think about this. It's SQL only. It's in memory, it's faster than disk, but it's SQL only. Any other benefits you can get, they don't have it. They only provide one significant benefit. If you are certain that you need only SQL in SQL only, and foreseeable future only SQL, then you can use that. If you need anything else, like streaming, or a MapReduce, or HPC, or a non-SQL store procedures, or anything else, or any type of scalability, because they don't scale at all, they don't scale beyond half a dozen boxes, you're out of luck, because they basically don't do it. They do one particular thing. Another major problem with these products, or this category, products, by the way, products are great, I love them both, but the category itself is that they require you rip and replace existing databases. Now, how many of you guys work in larger financial institutions? Think about this. You come into your boss saying, oh, well, we're going to get rid of this Oracle database right here. And see what kind of reaction you're going to get. No matter what the benefits are, no matter what the costs or what anything else, it's a very hard sale to do. It's very hard, ask to get to replace a database in a major organization because a lot of things attached to it. So that's one of the biggest problems with in-memory databases. They solve one particular problem only, and they require you to basically really, really marry into it because you have to really abandon your previous databases or migrate from it and basically adopt a new database, which is exactly the same SQL database you had before, but it's faster because it does something in memory. So that's the kind of the biggest negative through this. In-memory database have a little bit different flavor to that. And by the way, Apache Ignite is one of them. I mentioned the open source here, Apache GI, which is the former Gemfire. And there's a Hazelcast, and there's quite a few commercial ones that kind of die in the wine, which is a Terracotta and Gigaspace and Coherence Oracle. Those things are, we in Hazelcast replace them on a weekly basis in the major corporations. So the biggest difference between data grids and in-memory databases is that data grids are not only SQL. Most of them provide SQL, not all. Like Hazelcast doesn't. I think Geo does and Apache Ignite does provide SQL 99. But we also provide you the whole host of different capabilities, if you will. So we have MapReduce, multiple versions of MapReduce. We have streaming support for in-memory. We have obviously SQL 99. We have key value access. We have all kinds of different things beyond just a plain SQL. The negative about the data grids, think about this. What's the negative? It's got to be some negative, right? The negative is that you have to learn new APIs. Because if you use SQL, you already know SQL. You already know how to do it, right? To use data grids, you typically have to really learn something new. And that's typically I would say one of the negatives in data grids. So you have to really apply your brains a little bit, learn new stuff, and often enough re-architect some of the parts of data access and data processing in your applications. That's the negatives of that. Another interesting, two interesting capabilities of data grids. Data grids give you an absolute performance on a given hardware installation. There's nothing else that can touch the performance of hand-rolled, optimized data grid application. Let me give you one example. We won a pretty big deal. I'll talk about this in Sberbank. Sberbank is one of the largest banks in Europe. I think it's the largest bank in the world by number of customers. By assets, it's about, I think 7th in the world. But bottom line, think about this. We did a POC. It's a bank. Everybody can relate to this, right? It's a very simple bank. Not simple, but POC was simple. It's basically a trading analytics. And we achieved on 10 commodity Dell blades. Think about this. 10 commodity Dell blades with a terabyte of RAM total. We achieved 1 billion transactions per second. Billion transactions per second. 1 billion TPS on that hardware. Now think about it for a second, just to try to process this number. 1 billion TPS on a hardware installation costs about $25K. Just to give you a comparison, you can buy the best Exalytics from Oracle, best license from Oracle, max out everything, cost about $5–6 million. You get about $30 to $40 million, 30 to 40 million transactions per second. That less to do with GridGain or Ignite, but it has to do a lot with in-memory computing. If you do it right, obviously it was completely hand-optimized code and everything else. But you can do it. We did it on POC level. Nothing strange there. On the POC level, we achieved a billion transactions per second. Yes?
Quick question. Why would you compare to Exalytics and not coherence, the old dinosaur?
Probably, first of all, there was a lot of SQL involved in that, so coherence would not even do that because coherence has no SQL whatsoever. It has its own proprietary query language. But I get these numbers from that particular POC because they were, Sberbank is a heavy Oracle user. As a matter of fact, maybe Eric will correct me, but I think Sberbank claims to be #1 worldwide user of Oracle in terms of the payment store.
Single customer for it.
Yeah, so the largest single customer in the world for Oracle.
Oracle bought dinosaur, right? That became coherence.
Yeah, so we basically know the numbers from them. But again, don't think about it as something Ignite does very magically. It does, but it's less important. It's what in-memory can do for you if you do it right, with the right tooling, with the right approach. Yes?
So you spoke briefly about NetSQL and Ability, and you also spoke, I think she spoke about Ignite's ETL and data warehouse and how simple it is to import. So you were talking about foreseeable futures. If I'm starting off and I'm purely SQL, and this would promise even over to me, but if you have those facilities in place, why can't I just move from SQL and use Apache Ignite's features to actually do implementation?
So the question is, do we have to jump on this whole thing altogether, or can we start something with a smaller, right? Yes, look, across probably hundreds of the customers that I met throughout my life with GridGain, I don't think I've met a single one who use all of the features we have. It's always start with a small use case here. Hey, we need to do Monte Carlo simulation on these hundreds of nodes. Okay, do it here. Then all of a sudden, data comes into the place, right? It's, we need to have data sets, data grid comes into it. All of a sudden, we need to do a little bit more than just a key value access. So SQL comes around. So typically it goes this way. Every customer has a different mix. Typically, everybody gets to use data grid because that's where the key value access, that's where the map reduce, that's where the SQL, that's where MPP type of processing is. Compute grid is second. Naturally, if you need to do any kind of traditional high performance computation type of use case of processing, our compute grid is second to none. We're actually probably the best HPC platform in existence today when it comes to any JVM-based languages, Java, Groovy, Scala, anything you like. We have the best implementation for compute grid, bar none. Yes?
Do you think that graph databases could be helped by Grid?
Graph?
Graph databases like Neo4j.
Graph databases. I don't know. We do have the support for GUI indices in our SQL. GUI indices.
Oh, okay.
So we do have that as well. I do not know if we're going to immediately help particular graph database because we can help any database by simply caching it. But in terms of the graph database, I think we just have our own abilities to do the geographical indices already. Yes, on the back.
If you want to use this correctly, why don't you use another database?
I didn't hear you.
If you want this correctly, why do I need to use another database?
You don't have to. That's the coolest thing about us. And again, that's where I can kind of put my hat a little bit and say, look, we're better in this than practically anybody else. It's a big deal to have transactions in RAM, right? When you do transactions on the disk, you have a log, right? Log file, which is basically what's your base totally transaction recovery and everything else. When you do stuff in RAM, you don't have that specifically. So we spend years, and believe me, we've read every goddamn PhD paper in the last 20 years, related to the database design and everything else. By the way, we read all the papers by the guy who developed the voltage beam. So it took us a while, but we got to the point where we have a fully transactional behavior, fully ACID normal transactional behavior, both pessimistic and optimistic transactions. We have all the isolation levels, read committed, read down committed. We have an even serializable isolation level available to you if you need it. So couple this with a normal data replication across multiple nodes or across multiple data centers. That, you can have as many replicas as you like. As a matter of fact, you can have 10, 20 replicas of each data set. So that gives you a high availability and safety and durability of your data, which in turn makes, this system is completely capable of being a system of records. That's, if I answer your question, Yes?
As a follow-up to that, so you mentioned before, I want to make sure I understood that you could write every transaction to disk if the use case called for it.
Yes.
So in that regards, you could use this as an in-memory database and not use.
Yes, you can. As a matter of fact, in the second version, what we're developing right now is the roadmap. We're going to be able to actually have a disk-based data sets as well. So we're going to totally span both memory, flash, and disk as a one large virtualized data set. And your single query will work all over this. But back to your question, let me just tell you what we have. So you have an option, if you have a backend database, for every write in memory, you can save that into the disk. Not only can you do it transactionally, you can do it first, second level asynchronously, which is kind of relaxing the whole two-phase commit protocol. But you can also do basically write from behind, which is essentially you can buffer up those changes, right? And then write them up on the disk as a buffer, even further improving performance.
But that assumes a database as a companion when you do the.
It assumes any durable storage. We don't really care what the actual interface. We can work with a file system, we can work with a database or HDFS or Hadoop. If a particular data system has transactions, we're going to utilize those transactions as well. If it doesn't have transactions like file system, we will not utilize that. So, let me just, sorry, go ahead.
In Spark, I can take a file with JSON in it, and the records in there don't have to all have the same fields. I can have Spark, like JSON records that have different, fields in there. And I could register that as I could bring it in as an RDD, and I can register as a temp table, and I can do SQL over that, even though I didn't predefine the schema. It can all be inferred. Right. Can you do the same type of thing?
Absolutely. Not only we can keep the JSON zone. The question was, let me repeat the question. The question was, can we do the same thing that Spark does, basically keep a JSON document objects in the system and then query them? Yes, we can. Not only this, we actually went a little bit further. Not only we can keep a schema-less objects, we have that, like a JSON, a binary JSON. We have what we call a binary format, which allows you to, which is very cool. You can store a binary object from .NET and retrieve it from Java, and then store it from C++ and retrieve it from .NET, for example. We're going to convert all the types properly, which is pretty cool, by the way. All of you come from big organizations. You all have the .NET and C++ and Java people, right? So it's pretty cool when .NET people can work with a .NET native API, store .NET objects without any conversions or any marshalling, right in data grid, and right next second your Java people can just retrieve this object as Java. Yes? Sorry.
Yeah, so what are the limitations on this system with network because it seems like even if you're not hitting this, there's locking and coordination, serialization that's constantly happening. So it seems like network becomes your limiting factor as opposed to branch or situations.
It's interesting, it seems logically that you're correct, but I've seen very few examples where a network really became a factor. Because, we all advise our customers and clients to basically adopt an architecture design where you minimize data travel. Because think about this, if you don't do this, no matter what you use, Ignite or anything else, it will kill your system right away because network's just not big enough. So if you think about this idea of design principle that you're trying to minimize data travel as much as possible and keep data completely, static and only move computations to the data, which is the key for any distributed systems today, then the network doesn't really become a problem. Yes, if you're basically trying to do decode, unpack movie Netflix and trying to, move the movie over network, Netflix would not exist today. But Netflix is organized differently. In Netflix, movies never move. They get split up and they live in one place for any decoding. So only the decoding code travels to those pieces.
Is mainly use the use case of replication as well as synchronous transactions. So if I'm doing a synchronous commit with a replication, at some point I'm going to connect with that.
Yes, if you do replication, there's no, look, as much as you like, you cannot change the laws of physics. If you have to move the data, you have to move the data. In terms of the updates and replication, you have to move the data.
So how would a scenario like that compare with your billion transaction?
In a billion transactions per second, there was absolutely no touching the network.
Right.
I mean, believe me, you touch the network, forget about billions, forget about maybe millions. It was absolutely localized processing. So we were able to, so whenever the quotes were coming in, and that was a very simple scenario. This is in my portfolio, this is market quotes, can you recalculate the risk in portfolio, period. Very simple. So obviously the quotes were coming in, and we were able to completely localize any type of processing. So we know the affinity, so we know that, to recalculate, a S&P, we have to go here, or Russell 2000 go here. So we did that. So the only small quote would travel on the network, but the whole processing was happening localized, naturally. Think about this. If you calculate the billions, you quickly realize there is no way we touch anything other than CPU, RAM, and original travel of the quote over the network. There's nothing else involved.
Sorry, just one more
Sure.
sort of follow-up to that as well at the same time. So in that happy path scenario where you're highly optimized, churning out awesome benchmarks, how reliant are you on things like JNI and object storage?
You'll be surprised. We don't have a single line of JNI in our code. We have a little bit of a Linux optimization for inter-process communication. So we figure out that when the two nodes live in the same box, we can exchange data quickly, other than basically open TCP/IP traffic through a local host. But that's it. It's entirely Java-based and Scala-based, by the way, but it's a JVM-based code that basically does the work. And today's JVMs are very, very optimized. I mean, it's not like 15, 20 years ago when I started in late, early 90s. JVMs today are massively optimized. You don't have to do much at all.
Even Modern Station?
No. That's why we have off here.
That's the money when you have data on the heat. That's why I was asking about that.
Well, if you use something like GridGain, Ignite, or many other systems, you're right. It's a very interesting question that 15 years ago, nobody thought, oh my God, we have a 10 gigabyte of heap. Who would need more, right? Nobody has more. And today, your phone has more. And so today, if you talk to Oracle, they'll tell you it's the biggest problem in the Java community right now as to how do we, rejiggle the whole JVM business so we don't have this limitation of about 8 to 10 gigabytes of heap. But bottom line, folks like us solve the problem. We're completely transparent to you. Keep on putting stuff onto the Ignite. We will keep as much as in the heap, and we'll keep the rest of it off heap. And it's transparent to you.
So you are using off.
We're going to increasingly use more and more off heap and increasingly less and less of the on heap. There's just no other way around in Java world right now. Yes?
One of the problems we've seen in object databases and the rest is similar to that, around the level of profiling you do about what operations are hitting the network and what are staying local. What level of profiling like that does Ignite provide?
I don't think we provide anything specific to let you know what's local and what's not. You can do your own logging and just literally log this way and use anything like Logly to really collect this whole thing. I don't think even our advisor, which is our massive DevOps council, We have the log analyzer, but we don't really have anything specific to tell you what's local and what's not. It's very simple to see for yourself, just by logging, who's doing what job. Just from a design standpoint, we always almost enforce you or force you to do a proper affinity collocation. So we ask you to basically collocate properly your computations with the data. Because if you don't, I mean, you're gonna suffer dramatically performance-wise. So, hope I answered your question. So go ahead, please.
Yeah, in addition to that question that you said, you mentioned Netflix. It's not only Netflix or movements of the data that will involve the network. Even if you do like regular SQL, execution of optimization, so you parallelize that through your nodes and you push that, kind of like map side phase. And then you will need to do the shuffle before the reduce. So those nodes will need to move data to one or other nodes in order to do the second stage of the SQL optimization process, even theoretically. So you cannot, get rid of network completely or say that at some point I will be able to parallelize it. So, and then when you, like you say, when you touch a network, forget about billions or forget about even hundreds of millions at that point.
I don't know about your claim about second phase, because what we do in Ignite, well, it's actually a pretty interesting topic. So unlike anybody else in this space, we decided not to develop our own database, single database. What we do, pretty interesting by the way, on each node in the cluster, we run a localized H2 instance. H2 is a very highly optimized local SQL database that does all the execution plan optimization, all the basic SQL levels, and all the parsing. So all we do is we add distribution to it. So we intercept the SQL query, right? And we look at all the aggregate functions, all the where classes, and we basically just do distribution of that. We send out the pieces of execution plan on each node. Let each node do the local SQL execution as optimal as possible for the local data set. We collect it back.
Yeah, when you collect it back, it's network code.
But it's data. Yes, you're right. We're going to discard some of it.
In general case, it's not just one number that you do.
You're right.
Maximum
You're right.
or minimum.
You're right.
You will do joins and or outer joins, and you will be moving huge data sets. So you cannot get rid of network.
For joins, you're right. You're absolutely right.
So
if you're not
database processing without joins.
No. If you don't use a star schema, you're absolutely right. If you use a star schema for your joins, where you keep basically dimensions and facts, right? You keep, you can basically do joins very effectively. And if you don't do, look, again, it's a laws of physics. That's why databases don't scale, right? It's not because Oracle is not smart enough. SQL doesn't scale in joins wise. So that's, we're not solving the problem as well. So it's.
That's right. And if you will add indexes to that, then you even multiply that problem, because indexes do not distribute it and scaling distributedly either.
That's right. On the joins, you're absolutely right. On the indexes, I have to think about it, but on joins, you're right. Sorry. Yes, go ahead.
But the joins are within the actual cluster, which can be highly optimized versus in and out of the cluster, which would be.
Yes, you're right. We do joins in the kind of two steps. We do joins on each node, very effectively quick, and then we kind of do the final join optimization on the result node. So what he's saying correctly, that can be problematic if the overall set is big enough. I agree. But again, you cannot change the laws of physics. If your join result is big enough, well, guess what? With nothing we can do about it. Go ahead.
Can Ignite be used to synchronize databases? Like you have main Oracle and or like OLTP system and copy to one data warehouse. Is it like
maybe as a side effect, not as a key, not as a direct use case. I would, like in Sberbank, they use some kind of HP product to synchronize on the file system level, which I think is a better approach. EMC has the wonderful DSSD, if you guys have enough cash to buy it. Can you imagine this? EMC just came out with a wonderful product called DSSD. It's a flash-based product. It's about 5 times slower than RAM. Think about this. It's a centralized, network-attached flash storage. It's only 5 times slower than DRAM. I think it's a wonderful thing. They even developed their own cables. Think about this. So there's many solutions for that. I don't think synchronizing databases is You can probably build something on Ignite to do that, but I have no idea if it's going to be good or bad or faster or less or slower than whatever is provided. Go ahead.
You mentioned a few minutes ago talking about a binary data format. Is that like Avro or your custom format?
It's our custom thing.
Okay.
We tend to claim it's the fastest. We were like about 4 years ago, we had developed the fastest synchronization, fastest serialization in Java. We beat every other, prior and everything else. So we spent a lot of time building because, what Rachel said in her presentation, marshalling and demarshalling is the biggest killer in performance in Java side. Because you're marshalling and demarshalling major byte blocks into the objects and objects back to the byte blocks. If you can optimize that, which we did to the bone.
That's baked into the open source platform. It's not an extra add-on or not.
No, it's all part of that. Everything I'm talking about today, except maybe for UI, for management DevOps, is part of Ignite. Yes?
Can you briefly compare with Elixir?
Elixir, which is a Tachyon, right?
Yeah, Tachyon.
I still remember the new name.
It sounds...
So Elixir is, you know what? I'm not going to compare.
Okay.
Because I have no idea what Elixir would be. Because Tachyon, and I know the guys from Tachyon, Tachyon was a file system. Nothing more, nothing less. And we have a dramatically better file system. We outperform them by order of 10 at least. Today, Elixir, with all the money and the recent backing, they try to basically move in very different directions. And I have no idea what directions they're moving on. So they may end up be something like Ignite, maybe. But you have to ask really them. Because, I just really know as much as you guys know by looking at the website, which is awfully confusing. So, I don't want to confuse you much. I don't really know. As far as the file system, never use Tachyon. That's my recommendation. Use anything you can imagine except the Tachyon.
So you support ACID transactions within data sets. You talked about that. Do you support ACID transactions across different data sets?
Different? How different? What do you mean by different?
I've got positions and trays that I want to commit.
Oh, sure, yeah, absolutely, yeah. Everything you store in Ignite in a variety of different forms and shapes can be transacted, period.
But distributed transactions is a pain.
And we solve it.
How? Theoretically? I can see you in theoretical solution.
You got me on this one. So, two-phase commit transactions. If you first of all,
between first and second phase, you are screwed up.
Yeah, we're solving that protocol problems already. That's not an issue. So you're probably referring to the fact that two-phase commit transactions are slow. Correct.
No, it's not slow. They cannot always be automatically resolved. If the primary node who does the two-phase commits is your manager.
No, you can't. You can resolve it by failing it. That's a good resolution.
Who's going to tell you are failing?
No,
we're going to who is coordinated it died.
Oh well, we resolve that completely. So you're going to basically get an exception back from the transactions. You have to roll it back.
But how can you guarantee that if you got an exception, transaction is fully rolled back? That's the main problem.
No,
when you are okay, but when it's failed, you are not sure if it's fully failed, partially failed, or not failed at all.
No, we cannot do that, but we're giving you back the exception because you're right. Sometimes you have your own localized changes that you want to roll back, but we're giving you back an exception and give you opportunity to call the rollback and do whatever extra necessary to do that. No, we're going to do rollback on our own data sets. If you updated our cache or our data store, we're going to roll it back completely. But if you did anything locally or you called out 20 other transaction managers, we have no control of that. You have to do it, but we'll give you back at least an indication that transaction has to be rolled back. And that's it might be improper behavior.
I mean, you know to hold down during the commit. Now, who is going to make sure that when it comes back, the data will be rolled back?
Let me ask you the reverse question. How does it get resolved in Oracle database, or MySQL, or Postgres?
At least it's one node.
No.
It doesn't because it's theoretically impossible.
Right. So you have to look at your logs and do the manual reconciliation. So
but list of transactions is either fully committed or fully rolled back. And here you can have partial. That's the primary problem with distributed system.
But it's a problem, the same problem.
Go around the CAP theorem. CAP theorem still exists. If you have your partition, if your system is partitioned then you either can be consistent or available. You cannot be both. And in case of distributed systems, they are always partitioned because distribution means partition. You cannot be both. Cap theory says that.
You can choose two, but not all three.
But you don't choose partitioning, because partitioning is chosen. If you have a multi-node system, it is already partitioned because it's multi-nodes. And then in that case, that's all what we're talking about. We're not talking about one-node systems, because then you can go to the regular relational databases.
That's not the partitioning cap theorem. The partitioning is when the network breaks between the different machines. So your cluster is partitioned into.
That's right, but network breaks only when you have multi-node system. If you have one node system, there is no network there per se. It cannot break.
If you want a highly available system and a consistent system, you can ignore the minority part of the cluster and just go with the majority part.
Well, but in case that was pointed out, if that manager is in that minority portion, then you screwed anyway. You cannot ignore.
I'm talking about the minority in a peer-to-peer network.
We only got a couple minutes left of the presentation.
I think we're kind of done with the presentation.
Waiting to listen.
Quebec is a lot more interesting. But I think he is right. You know, we're doing exactly what you described. You know, we have what's called the split brain problem resolution. So we're picking the class that basically we believe is active, and we continue with the indication of the error. I don't want to get down to the deep weeds of the theoretical, because you're probably right about this, but it's the same problem with the majority of databases that are distributed.
Yeah, that's why when you say don't use transactions at all, then you are saying, hey, we have transactions. That's
You need.
Who's saying
everyone.
Yeah, since we're talking about the product roadmap, the MySQL and Snapdata provide the notion of growing column store. Do you have that in the roadmap, or column
Yeah, so very quickly. So I'll answer this question. So basically, there are kind of two trends right now going on. By the way, stick around for a couple of minutes. It's an interesting slide. So when we talk about the kind of this Converged data platform, there's two approaches that kind of bubbling up right now. The first one is a company called Snapdata inside H1 Gigaspaces and quite a few others in the Valley. It's basically grabbing the Spark and adding something to it, which is typically dedicated. And that's the idea of how do we combine, big data with OLTP processing, right? Spark is the big data thing with Hadoop in the back end, and dedicated gives the transaction and everything else. That's the one approach. We can like it or like it. I don't particularly like it because really, marrying, apples and oranges, and it's not really good. It's a hodgepodge of things. Apache Ignite is a different approach. We're trying to grow Apache Ignite into the use cases that will cover both OLTP, which we do today very effectively, and more in the lab, with a disk storage and SQL that spans the entire tiered data model. So we are going to be coming up with what we call a tiered model, where you have a virtualized RAM across RAM, flash, and disk. And in parts of that slower but has higher capacity, flash in the middle of that, and RAM has lower capacity, faster speed. But all your queries, all your processing is going to work exactly the same way. The more RAM you have, the faster it goes. The more disk you have, the slower it goes. But it's just going to continue to work perfectly. Same API, same everything, same approach. So that's what's coming up in Ignite 2.0. And we already have today, we don't have time, guys, but you can look at the website. We have the Hadoop integration and acceleration for Hadoop. We have a Spark, a shared RDB already built in the product. By the way, I'm sure you guys have used Hadoop, right? Think about this. Download Hadoop from Apache, stock Hadoop, run a pi calculation example, right? Simple as this, right from Apache. Then download Ignite, install it, change one line of configuration. Don't recompile anything, don't build anything. Run it again, 7 to 10 times faster. Think about this, zero code change, nothing to do, just download, install, run again on the same cluster. 7 to 10 times faster. Same code, no recompilation. That's the beauty, right? It's a plug and play acceleration, comes right there with Apache Ignite. So that's where we're going, basically. We're going to continue to grow Apache Ignite into the areas of HTAP, and translated processing. That's it for me. This is the last slide I have. Rachel and I, we're going to be here. And actually, we have the whole bunch of people from GridGain. John Capel is here. So our main guy in New York, right there. So grab one of us, and we're going to be able to answer any questions you have. Okay. Thanks a lot, guys.
Thank you, Nikita and Rachel. We are going to give away this drone right about now. So, has everyone had a chance to put their card in? I guess that's a no. So let's put everyone's card in. If you don't have a card, we have forms to fill out, but you probably don't have the time to get your paper out there. Anybody else? Going once, going twice. All right. Can I ask you, Rachel, to just reach in, mix it up? Mix it up, mix it up.
One? Okay.
Pick one and move that there. All right. Now, look that way and reach in and pick the whole one out. This one? All right, read it out.
All right. Mark Phelan.
Mark Phelan?
CBS.
All right, you won a drone. Congratulations. Everyone, Rachel and Nikita is here for one-on-one questions. Thank you all.